So friends, in the last class we have learned the adjacency matrix representation of graph, and this class I'm going to show you how we can implement the graph data structure using adjacency list. So here we are going to make use of the linked list concept and the array concept to prepare the adjacency list. If you have not watched the previous video where we have explained adjacency matrix, please go and watch that video before watching this one, right? So first let me explain what is the adjacency list representation of graph. Then we will be learning the code for that. So consider this graph which has got 4 nodes A, B, C, D, are also called as vertices, and 5 edges among those 4 vertices, right? So first let me show you the adjacency matrix for this graph. So this is the adjacency matrix. The 0, 1, 2, 3 represents the nodes A, B, C, D. Here 0 is A, 1 is B, 2 is C, and 3 is D. Let us assume that. So there is no edge from A to itself. So there is 0 from 0 to 0, right? So 0 is A. 0 to 1 means A to B. So there is an edge between A and B. So it is 1, and so on, right? So if I want to prepare a adjacency list for this, I have to use the linked list and the array concept to implement that. So this is the array to store the vertices, namely 0, 1, 2, 3. So here there is a link from 0 to 1. 1 is representing the node B. So let me name here. This node is 0, this is 1, this is 2, and this is 3, right? So here there is an edge between 0 and 1, that is A and B. So that is why the address of this node is stored in the pointer of this node, right? There is an edge between 0 and 2. That is why we have put a link in the first node to the node 2. So the node 2 is connected to node 3 because there is an edge between 0 and 3, right? So when we consider the node 1, I mean the node B, there is an edge between A and B and C and B. So that is why 1 is connected to 0 and 2. Here the link or the pointer field of the last node contains null because there is no node associated with this one, right? So the node 2 is connected to the A node, I mean the node with 0, and the node 1 and the node 3. So node 3 contains null inside the pointer field, and node 3 is connected to the 0th node and the second node, right? So likewise, so this is called the adjacency list representation, right? So this is called the adjacency list. Now let me explain the code to define the structures required for this adjacency list representation and the code to insert the new node. So I've declared a global variable called max node. So this is a constant which has got the value 4. So this is the total number of vertices that I'm going to have in my program, right? So here I'm using the structure to create the node. So node is the structure name which is going to create the node to store the vertex number. I mean to store the vertex. So a variable vertex num will store the vertex number, and the variable called next is a pointer which stores the address of the next node, which is again a vertex, right? So to store the address of the next node, which is also type of struct node, so this has to be also of the type struct node, and I'm going to rename this entire structure as node. That is why I used type def. So type def of this thing is node. Now this entire thing is renamed as node. Whenever I use node, that will consist of a integer variable called vertex number and a pointer called next to point to the next node, right? Okay, so this is the node that I've created using this structure, right? So this is the vertex number, and next is the pointer to store the address of the next node. So this node is representing this entire thing, right? So there are many other nodes also in the list. Okay, now I have to create a head node, right? I have to create a node which stores the address of this first node. So that is why I'm using the list. So list is a list of head nodes, each of which is going to store the address of neighboring vertices, right? So here this structure is named as list. Let us define that. So this is the structure, and I renamed this entire structure as list. So this is called as list. The node is called as list, and there is a variable called head inside this structure, right? So which is of type node, right? So this is of type node. So that is why it can hold the address of the first node in the list. So this head represents the variable here, right? So this will store the address of the first node. Okay, that's fine. We understood that. So just see here, this is called as the head variable. So this is the node list which I just explained, right? So one head node can hold the neighboring vertices of this node, that is 0. But I need a list of head nodes, an array of head nodes. How can I create that? So I'm going to use an array here called Adjacency, which represents the adjacency list of the node maximum of 4 nodes, right? Because I want to create a graph containing 4 nodes, so I have to represent those 4 nodes using 4 head nodes. Now using this I can create an array of adjacency list similar to this, right? So 4 head nodes to represent the 4 vertices, and I've initialized with 0, and the type of this array is list. Can you see here? The type of this node is list, and this can hold the address of the nodes, and I've initialized with 0. Later I'm going to change the content. Let's go to the next slide. So in the main function, now I'm creating the array of head nodes here using this for loop. When I equals to 0 until I remains less than max node, that means less than 4. So I'm going to create 0, 1, 2, 3 nodes. So here it is, using the malloc function I'm going to create a node which is of the type list, and this is going to allocate me a block of memory required for one list structure, and the address of the created node has been returned to in the adjacency list of I, that means adjacency list of 0. In the first block of array I will get the address of the first head node, and I will store null there. So this is what each iteration creates me. Now I got the list or the array of head nodes, and now I'm going to call the add node function by passing 0, 1. That means I'm passing the pair of nodes where I want an edge, right? And the add node function with 0, 3 and 1, 2. So I'm calling this function 3 times by passing 3 different set of nodes, and I'll call the print list function as well to print the list out, right? Let's go and study this add node function now. So here is the function add node. It takes 2 parameters s and d, whatever we pass from this here. So 0 is for s and 1 is for d, right? So that means for source and destination, and here we have created 3 pointers: destination, temp and source. All are of the type node, right? Okay, let's perform this. So this will create a new node, right? If and only if adjacency list of s head equal to null. So let's go and check this out. So here it is, adjacency list s arrowhead equals to null. That means adjacency list of 0, what we passed from the first function called 0, 1, right? Now let me store here 0 and d is 1. So just for the remembering purpose, okay, s is 0, 1 is d is 1, right? So adjacency list of 0, that means this node, right? So this is arrowhead equal to null, as it is. So now create a block of size node and return the address to source variable. So this is what we have got. right? Null. So now source is pointing to this node, right? So this has been created, and store s inside source arrow vertex num. So s is 0, that we got here, and that is got into vertex num, and source arrow next equals to null. So we have done that. Now store the address of source, the content of source inside adjacency list yes arrowhead. So that means now adjacency arrowhead will point to this now. So this is what happens, right? Okay, this is over. So this is the continuation part of this function. I just put it aside. So this comes here, right? Like this. Okay, let's study what is there. I will create one more node for destination, right? Using the malloc function, and this will return the address of the newly created node to the variable dest. And I will store the content of day inside dest arrow vertex number, that is 1 here, and null inside destination arrow next, right? So this has been created now. And now I'll use the temp variable to store the adjacency list yes arrowhead. That means, so that is what is the code here, and I'll run the while loop until temp arrow next remains not equals to null. So temp arrow next, right? So this is equal to null. So this gets failed. I will not get into the loop. So what happens here? The content of dest, that means this node, the address of this node will go inside temp arrow next. Temp arrow next is this, so this will point to this node now. So that is what happens here. So this represents the first node, that means the node with 0. So 0 is connected to 1. Recursively 1 is connected to 0. So that is what happened after this execution. So in the next call I'll pass 0 3. So 0 will be stored here and 3 is stored here, right? So everything now will be created freshly. Variable dest, temp, source, all of our pointers, all of them are pointers. Now again, let's start from the beginning. Adjacency list yes arrowhead equals to null. Is adjacency list yes arrowhead equals to null? No, this is not pointing. So this is pointing to some node. That means here it has not got null, right? So this will not execute. Only this part is execute. I mean, I'm going to create only the destination node now. Why is that? Because I already created this node with 0. So I'm going to do that. Using the malloc function, I'll create a new node whose address will be stored in dest variable. So here is that created. Now store d inside vertex num. D is 3, so store 3 here and null goes here. Now adjacency list yes arrowhead equal to temp. Now temp will point to this, right? Okay, and I'll run the while loop until temp arrow next remains not equal to null. Increment temp, that means store temp arrow next inside temp. What is temp arrow next? So it is not null now because this is the pointer, right? This is next, the address of this node. I forgot to change the content here, sorry for that. Now temp arrow next inside temp, that means the address of this node is here and that I'm going to store in temp. So now temp will point to this node, right? Okay, this happened. Now check, temp arrow next not equal to null? No, it's equal to null. In that case, don't go inside, just store the address of dest inside temp arrow next. That means this will come here. So this is the output, right? So this will no longer be pointer or null now. Okay, so this is over now. So now I'll call function again by passing 1 comma 2, right? 1 and 2. Okay, again adjacency list s arrowhead equals to null. So s is 1, so now it's pointing here. Is it null? Yes, it is. Before we join the list to this node, it is null, right? Okay, so this condition is true now. Now using the malloc function, create a node and store the address inside source. Okay, this has been created. Store yes inside vertex num, that is 1, and null inside next, right? So that has been over. And now store the content of source inside adjacency list as arrowhead. That means um, adjacency list adjacency list as arrowhead is this, right? Because it is 1. So this will go here. Okay, this is over now. Next, what is remaining? This will execute. Create a new node using malloc function and store the address inside dest. Okay, created. And store d inside vertex number, that is 2, and null inside next. Okay, that's created. And store adjacency list as head inside temp. Now temp is pointing to this, right? Okay, is temp arrow next not equal to null? No, it's not. Now store the content of dest inside temp arrow next. That means this will go here, and now this will point to this node, right? Here it is next. So that's it, we are done. So the list has been created. Now if you want to pass some more nodes, pass some more nodes and create list for this node, these two nodes as well, right? Now let's go and print it. So here is the function for printing. So this is very simple, you can trace it by yourself. So this will print the nodes, right? I hope you understood the code. If you have any doubts, please comment below, we'll try to solve it. Well friends, that's it for the class. Subscribe to our channel on YouTube, like our page on Facebook, follow us on Twitter, and join our group on LinkedIn. Thank you.